This is the video for homework 5, question 2. Okay, given the joint density function 1 over a y squared x, y is larger than 1, and x is between 1 over y and y. First, we have to draw the non-zero definition region of fxy. That is basically draw this definition region. That is, this is y over x, or x over y, and this is x equals y over 1. I'm sorry, 1 over y. So y is larger than 1, so this part. And x is between this curve and this curve. So it gets this zone up to infinity. And number 2, we have to find a so that fxy is a valid joint density function. Fxy being a joint density function basically means that integral, the double integral of the function in the area, in the shaded area, is 1. So we have to calculate this big integral. We start from this one. Pull the ay squared outside, and then find that the original function of this one is along x. So put in the limits. We'll get this. We can put 1 over a out, and this time that is basically 2 times this integral. And to calculate this integral, we have to make some substitutions. We let our z to be along y, and y equals e to the power of z. So this becomes this. Note that we have changed the integral limits. Now we simplify this one to pull the ez out here. So basically it is this. 2 over a times the integral of z e to the power of z from 0 to infinity. And then we calculate it real fast. Do the partial integral. We can find that it finally comes to 2 over a. And 2 over a equals 1 means a equals 2. And then the question 3, we'll have to find and draw the marginal density function of fx and fy. So fx and fy can be calculated in this manner. So fy is integral of fxy on x to both infinities. That is from 1 over y to y of this function. That is what we calculated, ln y over y squared, y larger than 1. And for y not larger than 1, that is otherwise, fy equals 0. And this is similarly for fx. Integral of the function on y limits to both infinities. And for x, we have to do this in 2 parts. Note that if we make integral on the x, it's divided in 2 parts, into 2 parts. On both sides of a. I'm sorry, both sides of 1. For x smaller than 1, fx is this integral. Integral of function from 1 over x to infinity. That is 1/2 to be. That is a constant. For x larger than 1, fx is a function integrated from x to infinity on y. And that is 1 over 2x squared. And we have now calculated the functions. We can draw the graphs. And number 4, we have to verify fx and fy are valid density functions. So we have to do the integration from both on both infinities and to verify whether it equals 1. This integral is from 1 to infinity, and basically this one, that is 1. That can be calculated to be 1. And fy is a valid density function that is well verified. So and for fx, the integral is divided into 2 parts, basically, from 0 to 1, this part, and 1 to infinity on this part. So, here, divided in 2 parts, and we calculate it. The first part should be 1/2, and the second part is 1/2 times 1 to infinity integral on 1 over x squared, and that can be calculated to be 1 as well. So fx is also a valid density function.